Good morning, student. Today we discuss temperature dependence of rate of reaction. It has been found for a chemical reaction with 10-degree increment in temperature, the rate constant become double or even more than double. Arrhenius was the first scientist who propounded a relationship between the rate constant and temperature. It is K is equals to a e raised to power ea upon rt. Here K is the rate constant, A is the Arrhenius parameter or Arrhenius constant, Ea is the activation energy, R is the gas constant, T is the temperature. Taking log on both sides, we get log base Ek is equals to log base Ea minus Ea upon RT. Because the value of log base Ea is 1 from mathematical table. Now, if K1 and K2 be two rate constants at temperature T1 and T2 respectively, then log base E K1 is equals to log base Ea minus Ea upon RT1. It gives equation number 1. Similarly, log base Ek2 is equals to log base Ea minus Ea upon RT2. Equation number 2. Now subtracting equation 1 from 2, we get log base Ek2 minus log base Ek1 is equal to Ea upon R 1 upon T1 minus 1 upon T2. Now log base Ek2 minus log base Ek1 may be written as log base Ek2 upon K1 is equals to Ea upon R 1 upon T1 minus 1 upon T2. Now we are converting log base E to log base 10 by multiplying it with 2.303. Thus the acquired relationship we obtain log base 10 K2 upon K1 is equals to Ea upon 2.303 R 1 upon T1 minus 1 upon T2. It is the temperature dependence of the rate of reaction. If we plot a graph between the log base Ek and 1 upon T, I repeat again, if we plot a graph between log base Ek and 1 upon T, we will obtain this type of graph whose slope is equal to minus Ea upon R and whose intercept it indicates log base Ea. So it is the temperature dependence of the rate of reaction. Now let us discuss effective collisions. The minimum energy which the colliding molecule must have in order that the collision between them may be effective are said to be threshold energy. I repeat it again. The minimum energy which the colliding molecule must have in order that the collision between them are effective are said to be threshold energy. Now let us discuss activation energy. The energy required by reactant molecule to form intermediate are said to be activation energy, or we can define it like this manner also. Activation energy is defined as the minimum extra amount of energy absorbed by the reactant molecule so as the energy become equal to threshold energy. In graphical manner we can indicate activation energy as, suppose here is the reactants, here is the product form. So the energy required by reactant molecule to form activated complex The energy required for conversion of from this position to this position is said to be activation energy. It is called activation energy. Here the energy, we are plotting graph energy and the reaction coordinate. If we plot a graph between the energy and the reaction coordinate, the activation energy graph is illustrated by this manner. Now let us discuss most probable kinetic energy. The kinetic energy associated with maximum fraction of molecules. I repeat again, the kinetic energy associated with maximum fraction of molecules are said to be most probable kinetic energy. For most probability kinetic energy, there is a graph like this manner, and this indicate most probable kinetic energy. Here the fraction of molecules, and here is kinetic energy. So it is a graph which indicates most probable kinetic energy. Now let us discuss collision theory. Collision theory. According to this theory, the reactant molecules are assumed to be hard sphere of identical size, and the chemical reaction is said to take place when they collide with each other. The number of collision per second per unit volume of reaction mixture is said to be its collision frequency. Suppose we have A plus B gives product. Suppose A and B are the reactant which on reacting give product. The rate of reaction may be expressed as ZAB e raised to power EA upon RT. Here ZAB is the effective collision between the reactant A and B, and e raised to power EA upon RT are the fraction of molecule having energy greater than or equal to activation energy. If we introduce another factor P, then we have an expression rate is equals to P ZAB e raised to power EA upon RT. Here P is the probability factor or steric factor. Now let us discuss effective collisions. The collisions in which molecule collide with different kinetic energies and the proper orientation so as to facilitate breaking of bond between the reacting species and the formation of new bond to form product are called effective collision. The proper orientation of reactant molecule lead to the bond formation, whereas the improper orientation make them bounce back and no product is formed. For systematic study, let us consider an example to clarify proper and improper orientation. Suppose we have CH3Br. Suppose we have CH3Br, that is methyl bromomethane. When OH negative react, it with two situation maybe arises. According to first situation, one thing must be noted here, the carbon is partially positive charge and bromine is partially negative charge. It's a partially negative charge. If OH negative, which is also negative charge, come nearer to this species, repulsion take place because the same charge repel each other and no product is formed. So this type of orientation is said to be improper orientation. This type of orientation is said to be improper orientation in which no product is formed. But in proper orientation, the reaction take place like this manner. Here the OH negative ion, when combines with bromomethane, in which carbon is positive and bromine is negative, attraction take place, result the formation of bond between carbon and OH, and also at the same time breaking of bond between carbon and bromine, result the formation of new compound called methanol with elimination of bromide ion. So this type of orientation is called proper orientation. I repeat again, proper orientation gives product while the improper orientation gives no product because bouncing back take place. Now two question maybe arises. Why the reaction of higher order less in number? Student, chemical reaction take place due to collision of molecules. The chance of colliding large number of molecules simultaneously is rare. Therefore, reaction of higher order less in number. Next question. Can a reaction have zero activation energy? I repeat again. Can a reaction have zero activation energy? If the reaction has zero kinetic activation energy, then Arrhenius equation comes out to be K is equals to A. That is, every collision result into a chemical reaction, which is impossible. Therefore, activation energy cannot be zero. Thank you very much.